Hey guys, this week we're going to continue talking about properties of matter, and this time we're going to focus on conductors and insulators. Okay. Again, whenever you're working with properties of matter, most of the time we're trying to separate or sort things out. We're looking at different matter and we're sorting the matter out. In this case, we're basing them off by the conductors and the insulators of electricity. Okay. We'll do a couple of experiments and then we'll see what is a conductor and then what is an insulator. All right. So let's get to it. All right, so right here, I have a little machine that allows the electricity to go through from one side to the other. If I touch this side and I touch this metal little wire, it should turn on. Okay, so that means the electricity is going through from the wire to my body all the way around to the other side. Okay, that's basically what a conductor does. It allows the energy to go through from one side to the other. So conductors allow energy to go through, insulators do not. Okay, so we'll talk a little bit more about what that is. The first thing I'm going to do is I'm going to test out these materials. So I have an aluminum foil, a penny, a wooden block, a plastic spoon, a marble, and a paperclip. Okay, we're gonna see which ones are conductors and which ones are not. All right, so I'm gonna grab it from one side and then hold the metal part to the item so that we can close the circuit. If it turns on, then that means it is a conductor. If it doesn't turn on, that means it is an insulator, which is the opposite of a conductor. All right. All right, so let's start with, I guess, this one right here, the aluminum foil. Again, I'm not gonna touch the wire because if I directly touch it, it turns on, okay? So I have to touch the item that I'm testing and then touch the wire. All right, so as you can see, it does turn on. That means that this item right here, which is the aluminum foil, allows the energy to flow through. That is a conductor, okay? So I'm gonna leave it on this side. Okay, let me scoot things back. So this is my conductor side, and then this side is gonna be my insulator side. All right, next thing I'm gonna do is a plastic spoon. What do you guys think is gonna happen? All right, let's test it out. Okay, it's not turning on. What does that mean? Okay, that means that it does not allow the energy to go through, right? Okay, very good. So let's move on. I have a copper penny here. And again, I'm gonna try not to touch the wire. So I'm gonna do it. Oh, there it is. Notice that I'm not touching the wire. The penny is the one that's allowing the energy to go through. So the energy goes through here and through the penny. So it conducts through the penny to my body back around. So it is a conductor. A penny, copper penny, is a conductor. Okay, let's do the marble next. Okay, and the marble does not conduct electricity. Okay, the marble does not conduct electricity. Put it on this side. It is the insulated side, conductor side. All right, let's do this wooden stick. What do you guys think? All right, so same thing. It doesn't allow the energy to go through. It is an insulator. Okay, insulators do not allow energy to go through, the energy to flow through. All right, and last but not least, we have a paperclip. And same thing, I'm only gonna hold it from the side. And as you can see right away, it's already conducting the electricity, okay? So it is a conductor. All right, so we do have 3 items that are conductors and 3 items that are insulators, which is good. Now, one thing I do want to focus on is what did these items do that these items didn't? Right, these items right here conducted electricity. It allowed the energy to go through. Okay, it gave permission for the electricity to flow through from one side to the other. Okay, from one side to the other, and then from one side to the other, so that it does close the circuit. These right here, instead of allowing it to go from one side to the other, it stops it right here, or it slows it down enough to where it doesn't have enough energy for it to continue to go around and around and around. So these stop it or slow it down, and these items right here speed it up or allow it to go through easily, right? All right, so looking at my chart, I have my conductor and an insulator side. I'm going to write a quick definition. Well, what do you guys think a good definition for a conductor would be? Conductors do what? Right? Conductors allow electricity, okay? They allow the flow of energy. Insulators is the opposite. So we can say it does not. So it does not. Not be my keyword, okay? Does not allow the flow of energy. Okay? And that's basically it. If you have a conductor, it allows the energy to flow through. If you have an insulator, it does not, okay? Does not allow the energy to flow through, okay? Remember, conductors creates a circuit, insulators do not, okay? Like for example, air right here is an insulator. Okay, I can't touch it. Like air is the one that's touching it, so it does not allow the energy to go through. Okay. All right. The last thing I do want to talk about is the conductors. Are all conductors magnetic? Okay. That's one thing that I do want to focus. Are all conductors magnetic? Because sometimes when you mix them, like conductors and insulators, and we mix it with another properties of matter, like magnetism, which we're going to do this time, are all conductors magnetic? What do you guys think? All of these three items allow the energy to flow through, so they are conductors. But are they also magnetic? Okay, what do you guys think? Oh, we're starting to see something. Okay, so if I place it here, the paperclip immediately came to the magnet. The other items, not so well. Okay, so what we can see is that some of the items are magnetic, but they're not all. But they are all conductors. Okay, so all three of these items are conductors, but they're not all magnetic. Okay, only some. In this case, is the one that contains iron. Okay, this item right here, the paperclip, contains iron. Therefore, it is magnetic. Okay, these items right here do not contain iron, so they're not magnetic, but they are conductors because they allow the energy to flow through. All right, that's the only difference between magnetism and conductors. Okay, so please do not get it confused. All right, guys, that's everything that we have for you today. Thank you for watching. We'll see you guys next time.